This is my first time in all. I've never been this far away from Manchester, though I go to London a couple of times. But it's really a cool town. I mean, I live in Manchester, it's a cool city, so if you compare that with Hull, it's a bit contrasted. But all the ways, I definitely love Hull. So my topic today, I'm going to be speaking on smart features, slower apps. I know someone might say to me, smart features, slower apps, why does he have a picture of that? Well, I'm just going to give you a bit of context to why I've decided to use that as my poster image. I'm Nigerian, and growing up, I grew up with my grandparents, and we used to do this thing called Tales by Moonlight, where you have all of the children gathered, and then you have the grandparent saying stories about animals. Basically, you see like a sort of moral ground, really. So they tell you all sorts of stories. Some of them are entirely false. And this guy right here is one of the interesting characters we usually look forward to listen to, because it was considered the smartest animal. Maybe I would say clever, but it has a way of, outchanging people and like going around in front of them and winning over them. So it's considered one of the very smart animals. And that's the reason why, with the way or how smart this animal is, it's also still considered as one of the slowest in the world. And that's where that comes in. So you can be smart and slow at the same time. Well, a bit of information about me. I've been doing software for 6 years now. I've contributed to open source, including the Microsoft Signal R SDK. That wasn't fun, because it took about 36 conversations to have that PR merged in. I also work with an organization called CodeBar. We sort of extend technology to people across the world, and we are in over roughly 16 countries. I take charge of the one in London, but I do that remotely, and I also go to the University of Derby sometimes to help with one-on-one coaching. I'm a mentor, I'm a speaker. I have an MSc in cybersecurity. I'm not exactly sure what I'm going to do with that, but of course, I have that at the back of my pocket. Away from that, I love fitness, a couple of 10Ks, and I've just completed my first half marathon about 2 weeks ago. And if anyone is into football, I support the best club in the world, which is Chelsea. Yeah. Right. There's some topics that really excite me. And one of those things is football. Another thing is software engineering and philosophy. But in 2026 alone, I have mentioned or talked about AI that I've talked about my favorite football club in my entire life. It's just this conversation of AI this, AI that, everywhere. On LinkedIn, even in Teams, everyone is talking about AI, which is quite exciting. For anyone who's a fan of movies, this I call the Infinity Stones. You have all of these great features that AI gives to you. Of course, you can have AI chat. You can do the autocomplete. Allows you to summarize large stuff into very tiny bits. And then you have the very fancy recommendations, content generations, and all of that. And AI features are very much expected, especially in 2026. But where do we draw the line between having really smart applications and having an application that's going to be a burden to our users? What I'm about to tell you today is drawn from production application. For context, application powers about 20,000 active users across 4 countries. So this is, think of it like a compression of a lot of chaos that's happened in the background. AI today, yes, feels like protein in fitness. For anyone that loves to go to the gym, there's just this thing that keeps coming up. protein. And if you put that into the context of software engineering and how we build softwares, AI is getting the same buzz. If your product don't have AI, people are going to ask you, why don't you have it? But the problem is, some of these things are really smart. It looks good on paper, but when you put it in the context of what your user needs and how you're able to satisfy your users, you get to see that it's just a lot of complexity that comes with it. The conclusion is that most AI problems, they're not really AI problems. They're more of a system design issue. And I think the couple of speakers that spoke before mentioned that. When you're building systems, decisions to make software architectures, design patterns lie basically on you, and you don't get to delegate that to the AI. You know, AI sounds cool on paper, but a few things to note. LLMs are very large, and LLMs don't just work alone. They have all of these external dependencies. Streaming responses, we're going to get to that in a minute, but streaming responses, they sound fast, but when you're rendering chunks of streams of data into your UI, it's not exactly that cool. The users want magic. They want things to happen with a click of a button, blink of an eye, but the browser wants to go at around 60 frames per second. You see where the conscience comes from. So the frontend becomes the place where AI complexity becomes very visible. Let's take a step back to look at traditional UIs before all of the AI buzz. Traditional UIs back in the days were just not so very far away. When I say back in the days, a couple of years ago. We have UIs that are very deterministic in nature. You click a button, you know exactly what to expect. But now, everything is changed. Let's look at some comparison from the old to the new. In traditional UIs, API calls are really fast. We had a mantra in my team then, where we said that all API responses must return between 200 milliseconds and about 750 milliseconds. And if you exceed that threshold, you have to take a little step back and retrace what you've done. The states are predictable. The responses are very structured in nature. And they had very clear failure modes. You could have 3 states and work with that all through your application. For front-end engineers here, you would have the loading state, the error state, and the success stage. Very predictable. But what happens when you introduce AI and the nature of your UI becomes very probabilistic? Then you start to experience things like long-running inferences. Your responses are not that structured anymore. And then you begin to have failure modes that are very ambiguous in nature. Let's look at the workings of what happens when we have AI integrated straight into our engine. The users don't see all of this. All they see is step 1 and step 8. But as engineers, a lot of things happen in the background. So a user comes on your app. Through the front end, sends in some user input. You have an API gateway somewhere. Think of an API gateway like a fence between the outside and the inside. And your API gateway carries this request and sends it to an AI service or an LLM, as the case may be. But the thing is, AI services and LLMs, they do a lot of computational work. As against when you have to make a request to the DB and just run a couple of queries and get your result. But with AI, it's a bit different. A lot of dependencies exist within the AI LLM circle. And you could see that, away from that, it goes into retrievals of information across, they call them vector databases. It does all these node connections, and then based on that, it gives you a response. There could be sometimes as well where you would have to make external calls. Say, for example, you're trying to get something. And for anyone that everyone uses it. Claude or whatnot, when you prompt your AI chat, you could see some information right at the top, like searching the web. Those kind of things is reaching out to external dependencies so as to give you more information. And then it streams back the response to you, and then you render in the front end. That sounds very, very straightforward, but it's not. When you look at the computational power that exists, when you compare a traditional UI and a UI that is integrated with AI. As engineers, I want to believe that whatever we're building, we tend to build for end users. Except, of course, if you're him, that's built stuff just to use on himself. But most of the time, we tend to build things for users. And we have to focus strongly on the way users perceive what we're churning out to them. So what exactly is the user experience problem? I'm a human being, and just like you, I'm very sensitive to waiting. So let's just play a scenario. If the request and response time takes around 100 milliseconds, it's quite fast, very instant, right? What happens when it goes to like 1 second? That's just like the time it takes for you to blink an eye. Fast. What happens when it extends to about 3 seconds? Me, as a person, as a user, at 3 seconds, you lost my attention already. I don't even want to hear it. To me, it's just come to me like, I don't think you know what you're doing. 3 seconds is a long time for you to give me a response back. I was talking about states the other time, and I just wanted to track back a little bit to the different states that we have when your UI is deterministic and when it's probabilistic in nature. You see how simple that is? The deterministic nature is quite simple. It loads, successful, or it's failed. But what happens when the states become very probabilistic? You begin to have something called state chaos. There's just a lot of states that you probably didn't cater for, and that's going to show up in your app. And of course, it's going to break the user experience of your application. And I just want to touch on something. It's called streaming. You know, streaming is, I'm just going to explain it in layman language. When you get onto ChatGPT and you say, ChatGPT, tell me about developer UpNorth conference. It does this thing where it says, searching the internet or whatnot, and it starts streaming the result to you. That is exactly how streaming works. Now imagine the time it takes to stream all of that response, the system holds off, and then waits till it has all of the information and dump it on you. You know, the time it takes to pack all of this information is quite a long time. And that's why streaming is very important when you're dealing with, you know, AI services embedded into your engines. Hallucinations. There's no way you're going to talk about AI and not talk about hallucinations. And hallucinations are not just AI problems. They are really user experience problems. Because in actual fact, users don't care whether your model failed, or maybe your retriever failed, or maybe your context was stale. They don't care. The only thing that's going to be in their head is, you know what, your app gave me very wrong information. And they're probably going to end up like that guy, angry. This is my favorite part. I've talked about our applications and just give background information about AI and where that starts in our application. We made a lot of mistakes, but I've just unpicked my 3 favorite ones. Because number 1, they are actually silly mistakes that shouldn't be done by anybody experienced. But we made the mistake, and I'm not very ashamed to admit that. So these mistakes, we made them. If you're making them right now, take notes. You don't want to repeat the same thing. And if you're looking to build something that's AI-powered as well, you need to avoid these mistakes. Right. No one should be doing that. Even at the deterministic level of traditional UIs, no one should be doing that. But of course we did. Before you tell me, or before you say, nah, that's such a basic mistake to make, just let me give you context. So our application makes AI search, and we had deterministic states. So we had some of those things seated in the DB, and when you search, we run these SQL queries that gives you the result. But then we wanted to enrich the experience for users. And then we say, you know what? When you give us the state of the things we have in our DB, try to reach out to LLM services and just give us more information. And that was where the problem started. So you would have a spinner loading for, 4 seconds, 5 seconds? And then the user is there like, what is going on? So that was a mistake we made. And what exactly could we have done better? Number one could have been to just return back the deterministic results. I mean, that one returns a lot, like less than a second. You give them that, and then you can progressively enrich the UI. For front-end engineers here, it could be in the form of looking for a scroll context, and then when it gets to the bottom of the page, you load more information. At that point, the users don't know that you are actually enriching the UI using AI recommendations. And of course, you can have the AI enhancements just coming later, and with that, you have a very good user experience. Mistake 2 was treating AI like a normal API. That wasn't very cool. Because for AI responses, they're usually slower, they're unpredictable, like we said. And in terms of token, they're very expensive. And this could impact a lot of things. You could have broken user experience, you could have unstable interfaces, there could be user friction, and of course, performance issue. Now, what would we have done better in this case? I was talking of streaming. Streaming could have been better. We send the chunks of packets of data returned from our API services and render them seamlessly on the UI. That could have helped us. And of course, you create a UI state for something I called fallback mode. Fallback mode is, I've looked at all of these states, and what is returned from the AI services doesn't match any of this. So we have something called the fallback mode. You fall back onto that, you show it to the users, and then you just show the error in a very cool way. The third one, and that's the last one that I've just unpicked from a list of problems, was overloading the client. We thought we were smart, and the engineers in the room were smart. They're jacked engineers. Some of them 10 years plus experience building software. And we wanted to be smart. I really don't have context into why we decided to do that, but it was one of those things we did. We pumped a lot of things into the front end, and we ended up with something called the fat client code. On the front end, we did things like prompt orchestration. We sort of handled memory in a way. We did embeddings. We did context assembly on the front end. That could have been avoided. So in retrospect, we shouldn't have done that. And I'm going to give us, before I leave, I'm going to give us like a simple architecture that we agreed on after a series of post-mortems and product meetings. And because I enjoy philosophy, I have a small quote over there that says a horse and a donkey might be similar from afar, but they're not exactly the same. I'll give you context to that in a minute. Right. On the ways we've talked about the mistakes, but then we picked up some really nice stuff on the way. Number one is that latency is now a product decision. Before, it used to be an engineering decision. You would sit down with engineers and you agree on agreed latency on your SLAs. You talked about, it's going to be like, we want to have 99p or 99%, or we want to have the return time to be less than a second. But that's moved away from engineering. Because you're dealing with something very unpredictable, the conversation had to be had at the product level. So you have to choose your trade-offs carefully. For anyone that does system design, when you're designing systems, we know, and it's common fact, that there's exactly no correct answer to designing a system. What makes your solution different from mine is the trade-offs I have to make. So you have to consider that when you are building systems that work with AI. I'm not going to go through that. But if you have to give better quality to your users, you might have to sacrifice faster user experience at some point. And this is basically a combination of, we can take one out and then leave one on the right. But it's basically something that comes from the business and then from the product. That was one of those things we found very cool. 2 is observability. In traditional systems, we want to have observability into requests and responses, or where does it go, audit trail, and all of that. If you have AI in your systems, there's a lot of things to look out for. Some of those things are token latency, the streaming interruptions, you could have hallucination patterns. All of this gives you enough data to be able to solve your issues when you start having them in the future. Another cool thing was caching. Everyone knows about caching. And I used to think caching was something like an holy grail of something that's just going to take away all of your problems. Just the way we think AI is going to take away all our problems. But one thing caching gave to us was low latency and high cost saving. And what are some caching that we did? Semantic caching, prompt caching, UI caching, all of this helped us. It didn't solve our problem, but of course, it gives us a bit of leeway to be able to do something cool on the side. Now, let's look at metrics. How then do we measure success for an AI product? For traditional UIs, and I keep saying traditional UIs because that's what we're used to. It's what we grew up building. I started learning code, though I started working professionally 6 years ago, but I started learning code in the era of Reddit and Stack Overflow. We don't even have that anymore. So when I say traditional, I'm just referring to that time. What we want to measure is just the API uptime and the response time. That's enough to say, I think we have a successful product. But it's a bit different when you have AI sitting somewhere comfortable in the middle of your system. You begin to worry about things like first-to-time token or time-to-first token, completion quality. You start looking at the abandonment rate. You start looking at the retry frequency and all of that stuff. Again, you need all those information to be able to make very rich decisions. Now, what's the recommended AI front-end architecture? And this was a conclusion we made after a series of product meetings. I think we had about 24 postmortems and a lot of head bashing, of course. But this is what we came up with. The front end should orchestrate the experience of your users, and the back end should only undo the intelligence, which is the heavy lifting. And the reason is this. On the server side, you have a lot of computing power, you have resources, you have CPUs, you have a lot of things that can do the heavy lifting. But on the front end, not so much, because you don't want to put pressure on where your system is actually sitting, which is the host. You don't want to put pressure on that. So you delegate most of the heavy work to the back end. And that alone can save you about roughly 60% of your problems. So, again, because I love philosophy, if the back end and the front end were sat down and having a conversation, the back end will say to the front end, leave what belongs to Caesar and take only what is yours. So it means that you take the very tiniest bit and do that, and then put all your problems on me. Now let's look at some of the things that the back end should be able to handle. At scale, should be able to do all of that. The construction of the prompt, the retrieval of the pipeline retrievals, the guardrails, the retries, the context assembly. You move that to the back end and let your front end undo just the experience. I have just 2 more slides and I'll be off. So we've talked about all of this. So I'm going to give you 4 key lessons and 5 key takeaways from that situation. First one is that users value responsiveness than intelligence. I've used bank apps that are so intelligent but are so slow. I'm not going to mention it. I have one of them on my phone, actually. It takes about roughly 5 seconds to load. But because my money is in there, I'll give them that I'll just excuse them on that. But users definitely value responsiveness than intelligence. In terms of efficiency, you could have a very small model. It's often better than a very, very heavy, slow, smarter one. And that points back to responsiveness. They just want something quickly as users. And then when it comes to the perception, passive speed matters more than actual speed. And that talks to AI streaming responses to you. You feel like it's fast. It's not. But what it's doing for you is just engaging you at that time so that you just have that passive latency to say, oh, you know what, it's fast. It's not bad. And then when it comes to experience, of course, good user experience can high latency, and the bad user experience can definitely amplify it. Now to my penultimate slide. I've said a lot, but if you don't take away anything, just take away these 5 things, or maybe like 2 or 3 that sound so cool to you. Number 1 is, in terms of architecture, AI changes the front-end architecture totally. And you can see that in the way you handle your states, in the way you begin to prepare for gotcha moments, and all of that. In terms of latency, we talked about the fact that latency is not an engineering problem anymore. It's now a user experience problem. Streaming is not free. Except you work for Google or you work for all of the very big companies, or you are very jacked when it comes to what you're doing. Streaming is a very complex implementation to make. Except, of course, we now have, I think OpenAI as a streaming SDK or something like that. But if we were to do that, it's not free. It's very expensive. And in terms of experience, of course, the way you orchestrate context and handle all of that stuff really matter. And in terms of pragmatism, faster, imperfect experience can often outperform slow, intelligent ones. Now, I'm going to leave you with this. Smart features are only smart if users still enjoy using your app. Thank you very much. And you can connect with me on LinkedIn and also check out my website, see one of the interesting things I'm doing. Thank you. Thank you.